So the topic for my IFM is analyzing social media network data using R. So communication on social media platforms is not only culturally and politically relevant, but also increasing widespread across societies. Users not only communicate via social media platforms, but also search specifically for information, disseminate it, or post information themselves. However, fake news, hate speech, and even radicalizing elements are a part of this modern form of communication, sometimes with far-reaching effects on individuals and societies. Basic understanding of these mechanisms and communication patterns can help us to counterattack negative forms of communication, for example, bullying among children or extreme political points of view. Forecasts assume that in the year 2021, the number of contributions of active social media users will increase to 3.02 billion per month worldwide. The importance of such contributions for forming a political opinion was especially second seen by the 45th President of the United States of America, Donald Trump. But fake news, hate speech, as well as radicalizing elements show an increasing number of social media platforms as well. However, such social media elements, often on seemingly harmless social media platforms like YouTube and accessible to children, can also be used to investigate communication patterns inside social networks. To focus the role of individual users and what influence the content of their comments and actions might have on the underlying structures of a social network. YouTube, for example, had 2.1 billion active users in 2020 and represent one of the most frequently used social media platforms worldwide. Along with the videos on cultural, political, or even private content, there is many comments, likes, and replies. So the software requirements for this paper was the working paper is written in R Markdown. So it uses the R programming language. A free software environment for using R is available on Linux, Mac OS by Apple and Windows. And when it comes to big data, R can also be used for unsupervised and supervised learning. There are ample of libraries built in. So now first is attaching the necessary packages. So the analysis of social media network data will require four additional packages in order to expand the range of the basic R functions, which are PLYR, Boson SML. So the Boson SML package will expand the range of R functions in order to collect data from popular social media platforms like YouTube, Twitter, or Reddit. So we can have access to these data sets. Then packages like MagRetive is used for keeping the necessary R commands tidy and structured. And the final package is stringer. And since text like social media comments is represented by character variables, the package will process and effectively manipulate individual characters within the strings. So that is why we need all these packages. Next is requesting an application programming interface. So basically, in order to perform analysis on social media networks, we need to have access to the analytical data of that network. This can be achieved by an API. An API can be used. We can have the API key for accessing that API because APIs are maybe public. So we can request the API for the YouTube data, and we can also use the API for generating data sets. So a Google developer's account is created in order to request an API. Each API will be assigned to a specific project. For example, social media analysis or big data analytics when it comes to social networks. Yeah, there are similar APIs for Reddit or Twitter, so we can use those too. Now, accessing data. Now, once a social media platform has been selected for the analysis, an access point has to be determined. And in this context, for example, access points can be relevant content on social media. Now, shifting to the example of YouTube, one could not only pick a video as an access point, but with content relevant to current affairs created by a person or on a specific topic. Now, each access point will be directly addressed by a unique identification number, which is assigned to each content on social media platforms. So, referring to the presidential election, we can have IDs created. So, YouTube will provide a news video called as US election Trump statement in full BBC News. Now, the news video has been watched more than 200,000 times within 2 days, and several users will have generated comments, likes, replies. Twitter and Reddit will provide similar access points, and it is possible to combine several access points separated by a comma between unique identification numbers. Next is generating a data set. We will use the collect command of the Votion SML package and refer to the generated objects API key YouTube and video IDs from the previous step in order to access YouTube. And the commands write to file, which has been set equal to true and verbose set equal to true, not only allowed to write the collected data to a file, but also to collect additional information on the process and data gathering if necessary. Now, a new dataset, my YouTube data, is generated from this by running this command. This str command and the head command will provide first insights into the initial dataset. Just to get a general overview of the dataset, we use these commands. And we need to pre-process the dataset, obviously, for tidying it, for cleaning it up. So that is the next step, the pre-processing. So first of all, we create a data frame so that we can have a better look at our data and we can use the methods which are applicable to data frames. So that is why we convert our data set into a data frame. And the first command, basically, we are uh, creating a data set which will have four variables: author, sentence, replies, and things. And summary will give us the insight on the data set. Okay. Next, we have the four variables, and the different types will be numeric and character as shown. And this will only hold true if all the variables include letters. The names of authors and comments as well as the written sentences will most likely include letters, so the author variable and sentence will be character variables. And since the variables replies and like will contain numbers, so we have set their type as numeric. Okay. The next step is yeah, this is the summary after doing all these steps. Now, next is inspecting the comments. By counting the number of comments of a user via the variable author, a new variable comments can be generated. Same procedure is applicable on the number of words within the variable sentence. Numeric variables on basis of character variables can be generated using the command comments count easy data author and comments frequency. This will simply count the number of comments by each author of a social media comment. Then we use the str split command in order to generate the new variable words. And only now, as one of the final steps of data pre-processing, double cases can be identified and have to be merged. And it is necessary for some because some authors of social media comments will have posted several comments. And the amounts of the numeric variables have to be summed up. So we use the ddply command, which is used for summing them up. And yeah. Next is analysis one, which is identification of cases and comments. Now, using this easy data set makes it possible to identify particularly active users within the social media network, which is done via the conjugated variables presented above. Now, as all users of social media networks will not get replies and likes, a first parameter for identification would be a predefined minimum of at least one reply and one like. That is probably the case when they have written more than one word. That is, if, for example, say 10 words. Therefore, they must have written at least one comment. The identification parameters can be specified. So we have specified that the replies have to be greater than one, greater than equal one, likes have to be greater than equal one, words have to be greater than equal 10. Only then we can classify them or we can use them as quantitative variables. The next step provides ordering. So in ordering, we are going to, as every user can be addressed by the username within the variable author, a user with a particular behavior can be analyzed individually. Now, the username with the variable author will provide access to the sentences that were originally written by the user. And this can be done with the recourse to the dataset of my YouTube data and the subset command. So this will focus on the 16th case, again displayed as an anonymized username, since all usernames have been anonymized for this working paper. This user will not only get the highest number of likes, but also has written more comments than other users and collected several replies. Next, we have identification of communication patterns. So a social network is characterized by active and less active users. In particular, active users tend to shape the communication patterns of social networks more likely than the less active counterparts. In theory, some of these active users seem to reach out to others in order to share their opinion. This is what makes them relevant for analyzing the social media network data. So above average active users and below average are identified using the summary command. Now the mean values that can be implemented in the if else command in the R terminal in order to create a new variable known as relevant. Presented below is the output of the new variable relevant, which can be found in the sixth column of the dataset. The variable has been generated as a binary variable, which means above average will be identified as 1, below average active users are identified as 0. It is also possible to convert the remaining variables into binary variables using this if else command. And the binary variables are also inspected here, so we can see the binary variables in the summary method. All predictors will vary between a minimum of 0 and a maximum of 1. Now, an adequate model would examine whether users who have the value 1 for the predictors also have the value 1 for the variable relevant. Then the weight of the predictors can be calculated, which are representative for communication patterns of any specific social network. A logistic regression model with the weights of the predictors as shown in the output. The weights can be found directly below the predictors, indicated by the names of the variables, and they vary between a minimum weight of 41.44 and a maximum weight of 42.61. The procedure by using such a model is also often used, known as artificial neural networks. Next is the visualization of social networks. The identification of cases and comments, as well as a basic understanding of communication patterns, are necessary for visualizing social networks. Thereby, the relevant users, as well as individual topics and the dissemination of these topics, can be made clear throughout the comments and replies of the social network. In order to do so, the initial dataset will be transformed into a dataset ready for visualization. So, activity networks. Activity networks are based upon the comments represented by nodes within each network and edges present like the direction of these comments, either to social media content itself or to other comments. The result is a graph object stored as an activity graph. Since graph objects as well as underlying data set of the activity network will differ from the common data sets in terms of data structures, the package iGraph is needed, and that is why we install the package. And the difference to a normal dataset will lead to a different way of writing commands. For instance, the names of the authors of the comments are now stored inside the sixth column of the variable nodes of the activity network. So this is how the activity network looks after visualizing. So suppose each comment is highlighted in red, the video itself is highlighted in red, each comment is highlighted in purple, focusing on the 16th page. That can be done by referring to this random and anonymized author ID and assigning him blue as the color, and it is also possible to highlight each comment that contains a predefined list of buzzwords, such as Donald Trump, President, or White House. One can add any number of buzzwords that have either occurred together, represented by an ampersand sign, and can also occur individually, represented by a forward slash. As a result, the distribution of the buzzwords can be visualized throughout the entire social network. That is what we are seeing here in the activity network. And then we can see for different kind of topics like music, sports, games, politics. We can see the activity networks visualization as per the buzzwords which are specified by the in the code. Thank you.